Hi Algebra! Today's lesson is going to conclude Chapter 8, which was Operations of Polynomials and Factoring Polynomials. I cannot believe we made it through this entire chapter. It's really tricky and you guys have done an amazing job. Factoring does not go away though. It will be 1 out of 4 ways that we solve quadratics, which is the next chapter. So you can look forward to seeing it again. So what we have left for factoring to learn is how to factor completely. And you guys know all the pieces to factoring completely, but today we're going to put it all together. So for factoring completely, I have a list up here. It's kind of like a checklist and you can kind of keep it as a running checklist. And as you're solving each problem, you can start back up and make sure you've hit all of these points to make sure that you're completely simplified. The first step to factoring any polynomial is going to be to pull the GCF out first. Always. It's going to make your life way easier. You're going to be dealing with smaller numbers. So factor out the GCF first. And I'm going to add on to that too. We're going to factor out so that A is left negative. So for example, if I said factor this polynomial, if I said to factor that polynomial, I would want you to factor out a -1. It's going to make it easier for you. Next, we're going to look for special product patterns. Remember, there's that perfect square trinomial that you do not need to recognize. Difference of squares you are going to need to recognize. If I have 4 terms that I'm working with, so for example, this one here, there's 4 terms, I can start off by just splitting it right down the middle, and we'll look what that looks like in a minute. For trinomials, if A is 1, we can do just our x and go ahead and just use those factors. And if A is greater than 1, we need to do our x method and split. So make sure you know the difference between those two, that's important. And that's pretty much it. You're going to go through and we can kind of check these off as we go. Today I put together 4 examples for you to watch me do, and then I have 4 for you to try on your own, and they look just like these examples. So the first one that we have up is a trinomial. And the first step, as always, GCF first. So I'm going to pull my GCF out and I can see right away that 4 is the biggest number that can come out. And I also see that A cubed is the most of the A's that can come out. Now what I'm left with here now is A squared plus A minus 30. So I factored out my GCF. I don't see any special product patterns. It's not a 4-term polynomial. So what I'm left with in here is a trinomial. And I have a trinomial where A is 1, right? So this is just going to be, do my x method and I can pop my factors in. Not a complicated one. So here I'm looking for what multiplies to -30 and adds to 1. So you could do your list of factors if you wanted to, or if you knew right away that I could use 5 and 6. And I'm going to make my 5 negative. -5 times 6 does multiply to -30 and also adds to 1. I'm not going to spend too much time on that because you guys have already spent a lot of time on it. So I can go ahead and put -5 and 6 in my binomials. You're not going to forget about this part out front. This is that new part of today. And I have A minus 5 and A plus 6. And now this polynomial is factored completely. It is completely simplified. You would be done with this, and we're including that 4A cubed in our answer. When you factor completely, you want to make sure that if I multiplied all of these factors together, that they multiply back out to the original polynomial. That's why we're including this piece as well. The next one we have is another trinomial. This one though, watch what happens when I factor out my GCF. And you guys have dealt with these last week, so you know what you're doing here already. If I factor out my GCF though, that part's new for this. Some of you saw it in Zoom if you came to the Zoom, one of the Zooms last week. I can factor out a 7. When I factor out a 7, I'm left with 2b squared minus 5b plus 3. And now I'm dealing with numbers that are a lot smaller. If I had not factored that GCF out, I would have had to multiply 14 and 21 to find the factors of that. And that would have not been a fun time. Now I'm able to deal with, in my x, 2 times 3. And 2 times 3 is going to be 6. And b is my bottom for -5. And the 2 factors that I'm going to use here are -3 and negative 2. I'm using those because negative 3 times negative 2 gives me a positive 6, and negative 3 plus negative 2 is a negative 5. Now I'm going to keep my 7 out front. I'm just going to put in parentheses so I don't forget about it. And I'm going to rewrite this trinomial using the split method to rewrite that negative 5b. So I have 2b squared minus 3b minus 2b plus 3. So you guys have seen this before. I'm going to split right down the middle when I have 4 terms, split it down the middle. And I'm going to pull out what I can for a GCF on each side of that split. On the left-hand side, I'm able to just pull out a b. When I pull out b, I'm left with 2b minus 3 left on the inside. And I need to make this match, as you guys can remember from last week, I need these two to match. So in order to make my front term positive and my second term negative, I'm going to need to pull out a negative 1. And now I'm left with 2b minus 3 in my binomial. I also don't want to forget about the 7. Sometimes kids like to write it every step of the way. Sometimes kids like to leave it up here and pop it back in at the end. That's up to you. What I do know is I have a 7 out front. I know that this makes my second binomial, although the order doesn't matter. You could also flip these all around if you wanted to. Times 2b minus 3. And this is factored completely. If I multiplied these 3 factors out, multiplied them by each other, I would end up with my original trinomial up here. All right, this next one is a little different than ones we've seen before because we're starting with 4 terms. We've done a lot of work with trinomials, ones with 3 terms. And the rules in the beginning that I had told you about, if we have 4 terms, we're just going to split it. So this is almost as if we're starting at this step when we split the trinomial up, when we rewrite that middle term. So same thing, I have 4 terms. I'm going to split it right down the middle, and I'm going to find the GCF of each side of that split. So the GCF on the left, I see that I can pull out 6 for a number, and I can also pull out c squared. And when I do that, I'm left on the inside with 7c minus 4. And I need these to match. I need them to match. So in order to make them match, I'm going to pull out a negative 1. Now I'm just going to rewrite. I know I have 7c minus 4 as one of my binomials times 6c squared minus 1. And that is factored completely. There's nothing that I can pull out of those to make it any more simple than it already is. I've got one left, and this is one that a lot of people were missing on the forms from last week, so I wanted to be sure to go back over it. This is actually going to end up being a difference of squares, and a lot of kids missed that because we weren't factoring out the GCF yet. So if I factor a GCF out, which should be the first step no matter what, if I'm able to, I can go ahead and factor out a 2 here. And when I factor out a 2, I'm left with 16d squared minus 1. And this is that pattern that you've got to recognize in order to be able to factor completely, now that we know what that means. I have a perfect square minus a perfect square, difference of squares. That's where the name comes from. So I have a perfect square minus a perfect square. You guys need to know that that pattern means I'm going to multiply 2 binomials. One's positive, one's negative. And the square root of 16d squared is 4d. That's where I got my front term of those binomials. And the square root of 1 is 1. And that is factored completely. 2 times 4d plus 1 times 4d minus 1. So I tried to give you 4 good examples that really have pieces of each of these steps in them. And I want you guys to try those on your own. The try on your own, if you're following on the notes, are right below it, and they look just like the examples we just did. So for the first try it on your own, it's 5a to the power of 4 plus 40a cubed plus 80a squared. Write that down, or you can start doing it if you have your notes printed out. The next one is negative 10b squared minus 5b plus 75. I want to give you a quick hint on this one. You want to make sure to factor out a negative number when you're doing your GCF to make your leftover leading coefficient positive. The next one is going to be 32c cubed minus 12c squared minus 56c plus 21. And last, we have 50d squared minus 18. So those are set up, the variables match. So the ones in the top left, if you have the notes, are both A, the top right, both B, C, and then D. So if you're at home now, I want you to pause this and fill in your notes or sketch these out on some scrap paper to make sure that you're confident with what you're about to do on the Google form for tomorrow. And I'm going to show you guys the answers now with my work. You guys know the drill. You're going to pause it. If you did not get what I got, then I want you to try to find your mistake. If you don't see it, please reach out. For this one, I just want to point out quickly that you can either write out your answer like this, but I have the same binomial, so I can just write it as a squared term as well. Those mean the same thing. For this one, I gave you that hint to factor out the negative. We want to leave a positive a term in there, a positive leading coefficient. And I end up with negative 5 times 2b minus 5 times b plus 3. If you wrote it in a different order, that's okay. For the problem with the variable of c, I'm left with 4c squared minus 7 times 8c minus 3. And last but not least was our difference of squares one. I have 2 times 5d plus 3 times 5d minus 3. So that is the end of chapter 8, guys. Again, congratulations. This was not an easy chapter, especially to do from home. You guys are doing an amazing job, and I look forward to hopefully seeing some of you this week. Bye-bye.